Let's look at string indexes.
The string attribute in Dgraph is very unique in the sense that it has several different types of indexes available. These include hash, exact, term, full text, and trigram. We will look at some use cases for each of these indexes. Now let's imagine that you have some attributes associated with a person. The record ID attribute uniquely identifies the person. This type of attribute is a candidate for the hash index. Let's look at an attribute like name. In addition to being able to identify a particular node, this attribute is also used for alphabetical order comparisons such as greater than, less than, and so on. Such type of attributes are candidates for the exact index. Let's look at the favorite dishes of this person. Any attribute which contains lists of well-defined terms, nouns, and so on are candidate for the term index. List of countries, cities, currencies are very good candidates for term indexes. Now let's look at some more attributes like street name and address. These are very noisy fields in the sense that when users search for data around street name and addresses, often the data does not have very good quality. You may want to have some elbow room for fuzzy comparisons. The trigram index is ideal for such fields. Finally, you may have data which is completely free flow. For example, email content. So in this case, a quotation from the user, "I like playing soccer," is a good candidate for a full text index. Let's save this data. Let's now also review the indexes. These have already been set up. So you have the record ID, which is a hash index, the name, which is an exact index, the favorite dishes, which is a term index, the street name and address, which are trigram indices, and finally the quotation, which is a full text index. Great, we are now ready to query. Now let's look at the options for querying. As mentioned earlier, the record ID uniquely identifies a person, so the equal to option is available and is supported by the hash index. The exact index, in addition to supporting the equal to index, supports alphabetical comparison. So the greater than equal to comparison is supported here. Let's move on to the term index. Since the favorite dishes uniquely points to list of terms, the any of terms can be used here. There's also a variant of the terms-based query called all of terms, which you can use. Let's look at the street match and the fuzzy searcher on address. Let's assume that someone is looking for the address, and instead of writing the digit 1 Main Street, the person has entered the word 1 Main Street. In this case, we can use the match index or the match query supported by the trigram index, which helps us to arrive at what data is stored. So here what we are saying is that if the difference between the alphabets that make up the querying field and the actual data is just 3 characters, then it's a match. This is done through the Levenstein algorithm. The fuzzy search around address uses a regular expression. This is also supported by the trigram index. And finally, by using word stemming, which is supported by the free text search, we can search for a word which is not even there in the quote field. So in this case, the play field, or rather the play text, should match with the playing that we mentioned while we mutated the quote field. Let us run these queries. So as you can see, we are able to uniquely find the record ID. We are able to look at John as greater than equal to Alan as per the alphabetical order. We found the dish by using the any of terms query, we matched the main street correctly. We also did a fuzzy text match on the address field, and finally we used the free search capability using the word stemming around play to find the text I like playing soccer in the code field. Thank you.